This video is going to cover Unit 27, Sections 1 and Section 2. Section 1 deals with the areas of circles. Okay, so the area of a circle, the equation is area is equal to pi r squared. Okay, and we know that pi is equal to approximately 3.14. And the radius is equal to the diameter divided by 2. So knowing that the radius is the diameter divided by 2, I can write this equation using the diameter. So area is equal to pi times the diameter divided by 2 squared. So why would we want to know, why would we need two different ones? If you have the radius of a circle, it's best to use this. However, let's say that you're working in a shop and you have some bar stock. Let's say you've got some stock and you need to know what that surface area of that is. Maybe you need to calculate the volume of the bar stock in order to find out the weight or something like that. But if you need to know what the surface area of this end is, it's very difficult to find the radius of that. How would you measure the radius? Well, you'd have to know where the center is, but it's not so easy. But you can take a tool and you can very easily measure the diameter. All right? So that would be a case where you would use this equation instead of that one, if you could find the diameter by measuring it. So let's say we've got, let's see, what kind of example do they give us here? .14 is enough for pi. I know that Weird Al Yankovic knows pi to 1,000 places, but we only need to know it to 2 places. That's good enough for almost everything you'll need to do. Unless you have pi on your calculator, then you can get the exact number. But I usually just use that. Okay, so if we had a circle, I didn't get my template out, but let's say we have a circle. Who needs a template? And the radius is 22 inches. And we want to know the surface area of that. So we would just say that the area is equal to 3.14 times 22 squared. So 3.14 times 22 quantity squared is 1,519.76 inches squared for the area of that circle right there. So that is area of circle. Now let's look at 27.2. The ratio of two circles. Okay, if you take two circles, the area of the first one divided by the area of the second one is going to equal the radius squared of the first one divided by the radius squared of the second one, and that is also going to be equal to the diameter squared of the first one divided by the diameter squared of the second one. All right? So this is just some ratios for the radius. squared, the diameter squared, and the area of various circles. So let's take a look at the first example there on page 682. All right. The radii of two circles are 5 feet and 2 feet. So 5 over 2. And we would need to square them because it's radius squared. Oh, they give it to you. It's right there. Is 5 squared is 25 divided by 4. So the ratio of the sides, or the radius squared, is 25 to 4. So therefore, the ratio of the areas would be 25 to 4. So what they do is they divide 25 by 4, and they get 6.25. So the area of this circle here is 6.25 times the area of that circle right there. So what is the area of this circle? 3.14 times 25, 78.5. The other one is 4 times 3.14 is 12.56. Well, let's take that 12.56 and multiply it by 6.25. And I get 78.5. Ta-da! Now, on that same page, just a little bit lower, on page 682, we have another setup which says that the radius, I'll write it over here, the radius of the first circle divided by the radius of the second circle is equal to the diameter of the first circle divided by the diameter of the second is equal to the area of the first divided by the area of the second, but this time we need to take the square root of the areas. Now, these two are similar, okay? So let's take a look at where they're coming from. So if I take the square root of all of that, I'm going to get the square root of A, which is there, the square root of R squared, which is R, and the square root of D squared, which is D. Okay? So this ratio right here is just simply taking the square root of this ratio right here. All right? So if you've got the area of, what example did they give us? The area of one circle is 36 centimeters squared, divided by the area of another one is 9. So if I take the square root of each of those, square root of that is 6, the square root of that is 3. So that means the ratio of the radii is going to be 6 to 3. Or, in other words, 6 divided by 3 is 2 over 1, or just 2. So the radii of this circle is twice the radii of this circle. The diameter of this circle is twice the diameter of that circle. All right, so let's take a look at page 684. We're looking at figure 27-5. All right, so we've got, let's see here. Let's go to the good side, the inches side. And, well, I guess there's millimeters in there too. Oof. All right, so we've got the area of one circle. The area we're given as 380, what is that, millimeters squared? Millimeters squared. I'm looking at number 13. And what we're looking for in this case is the radius. So if I look right here, here's my formula. So what I have here is 380 is equal to pi, which is 3.14 times the radius squared. Well, I divide out 3.14, divide 3.14, and then I have to take the square root of it. So 380 divided by pi, 3.14, is 121.009. I'm going to take the square root of that. I'll just raise it to the half power. And that tells me that the radius of this circle is equal to 11. So let's prove that to ourselves. Let's put that back into this equation. Okay? So pi, 3.14, times 11 squared, which is 121, is equal to 379.94, which is, I mean, a little rounding here, which is 380.